Hello students, I am Ishan Trivedi, Assistant Professor, Civil Engineering Department. Welcome you for the lecture series. Today's topic is building components. Topics to be covered in these sessions are building components, which further classified as substructure and superstructure, and at last summary of entire building section with its dimension. Let us start with the components of a building. First is substructure. It is the lowest part of a structure below the ground level, which is in the direct contact with the surrounding ground and transmit all the loads to the ground, such as foundation. Here one example has been shown. You can see here the upper structure load, which carries by slab, walls, beams and columns, which is transferred to the subsoil below through foundation, and this load will be distributed to the ground. Next is superstructure, the part of the building which is above the ground level and which serves the purpose of building's intended use. The components of superstructures are plinth, walls, column, beam, doors and windows, window sills, chhajja, lintel, coffin, parapet wall, slab, building services and building finishes. Let us have a brief introduction of substructure. As I said earlier, substructure comprises with foundation. Depending upon the type of soil existing at a site, its safe bearing capacity and the type of building which is required to be constructed, and a structure may be needed as shallow or deep foundation. The shallow foundation is called where the depth of foundation is less than 3 meter, whereas deep foundation where the depth of foundation is more than 3 meter. Example of the foundations are spread footing, combined footing, strap footing and rough foundation, which is part of shallow foundation, whereas the pile foundation is part of deep foundation. Here some images has been given like slope column footing, simple pad footing, simple column footing, spread footing, stepped footing, stepped column footing. In this subject, we are not going to much detail about foundation and its types because it depends upon the structure which is going to be built and the subsoil below. On basis of that, the foundation has been determined. In this particular subject, the detailed classification of foundation is been not studied. We are just focusing on the dimension of the foundation. So let us discuss about the foundation and its dimensions. As we know that buildings are comprises with walls, slab, columns, beams and foundation. The upper structure load or slab load or roof load is being transferred through beams and columns and wall to the subsoil below through foundation. If the thickness of wall and the outermost side of a residential unit is of 30 centimeter, remember this, the outermost side or you can say periphery of the building, the thickness of wall is 30 centimeter. In the inner side of the building, the wall thickness is of 20 centimeter, whereas in partition wall, it would reduce by 10 centimeter. So let us take an example of 30 centimeter wall and its foundation. If the wall having thickness of 30 centimeter, then the base foundation of concrete base is determined by the simple equation, that is 2t plus 30. Here the thickness of wall is 30 centimeter. So that by putting the value of 30 centimeter in the equation, it will be 2 into 30 plus 30. That gives me the answer of 90 centimeter. So the concrete base at the foundation base having width of 90 centimeter. Subsequently, if we are providing step footing in a building, then the footing will be in consecutive parts. That is of first stage, second stage and third stage footing for the outer wall only. The entire structure of step footing will be of brick masonry. If the thickness of wall is 30 centimeter, then as we construct the concrete base of 90 centimeter, the first footing will be of 60 centimeter. From either side, I will cut 15 centimeter projection. Above that first footing, now the projection of 5 centimeter from the either side will be cut and second footing will be done, that is of 50 centimeter, and the next stage third footing is been placed, that is of 40 centimeter. In this case also 5 centimeter from the either side has been reduced, and ultimately you will reach to the thickness of main outer wall, that is of 30 centimeter. The entire footing from its concrete base to third footing, the depth of each layer is of 30 centimeter. Remember, the depth of each footing is of 30 centimeter. If I do summation of all this brick masonry and concrete base, it will be of 1.2 meter in total. This is the case of outermost wall. For the inner wall having thickness of 20 centimeter and applying the same equation for concrete base, it will be of 70 centimeter. So this concrete base for inner wall will be of 70 centimeter. Next is we will provide first footing and second footing, but the third footing is not being constructed in inner wall. So there will be only two steps of brick masonry work, whereas the bottom layer is of concrete base. Once we reach to the ground level, by providing all those footings, the plinth will be start. The minimum plinth height is 45 centimeter. It is also vary with the type of construction. This will be detailed out later on. Now study superstructure. Superstructure, as I said, it comprises with various building components which has been constructed above the ground level. The superstructure comprises walls, columns, beam, slab, floor, roof, stairs, coping, parapet wall, window sills, building services and building finishes. Let us understand the plinth. It is the portion of a building between ground surrounding the building and the top of the floor immediately above the ground is known as plinth. The level of surrounding ground is known as ground level and the level of the ground floor of the building is known as plinth level. The plinth height should be not less than 45 centimeter from the surrounding ground level. As I said this, plinth includes damp-proof course, flooring, earth filling and bed of concrete. In previous session, we left with foundation and reached to the ground level. Above this ground level, there will be a bed of an earth filling, or you can say compacted muram filling, having thickness of 20 to 25 centimeter. After laying this earth filling, it has been rammed, hand rammer or mechanically operated rammers. As we achieve the firm ground, then there will be laying of concrete bed having thickness of 10 to 15 centimeter. Again I am repeating, there is earth filling or you can say compacted muram which is rammed by hand rammers. Then there is a layer of concrete bed having thickness of 10 to 15 centimeter. Above this, once the bed has been achieved, a flooring level or you can say flooring has been placed. Flooring can be achieved by different flooring material such as mosaic tile, marbles, stone, sandstone, granite stone, vitrified tiles and so on. With the same level, the DPC means damp-proof course has been provided just below the opening, or In many of the cases, it will be provided at periphery of the building just above the plinth level. Remember this, it will be provided at the periphery of a building unit just below the wall. And to avoid the dampness which strike from ground level to the floor, we provide damp-proof cores. Next building component is walls. Load-bearing walls transfer the load of superstructure to the plinth. Walls are provided to enclose or divide the floor space in desired pattern. It also provides the privacy, security and protection against sun, wind and rain. As I said earlier, the outer wall thickness is of 30 to 40 centimeter, the inner wall thickness is of 20 to 30 centimeter, whereas partition wall having thickness of 10 centimeter. The outer wall is of the peripheral wall of a building. The inner wall is being provided to support the structure at certain interval. And at last, the partition wall of thickness 10 centimeter is being provided just to achieve the privacy of a building element. Like we provide a partition wall in toilets and bathroom just to achieve the privacy of that particular area. The partition wall does not take any load coming from the roof slab or from the upper structure. Remember this, partition wall does not take any load coming from the roof or any superstructure. Next is floors. Floors are flat supporting element of a building. The basic purpose of a floor is to provide a firm and a dry platform for a people and other items like furniture and equipments. As I said earlier, flooring is provide a firm surface, and this will be achieved by providing different flooring materials such as marble, stone, kota stone, vitrified tiles, mosaic tiles and so on. Next is column. It is defined as an isolated load-bearing member. Column transfers the load coming from roof or slab through beams and transfer the load to subsoil below to the foundation. The columns are of different shapes and size, like it is of rectangular, circular or square in shape. The size would be vary with 15 centimeter by 15 centimeter, 20 centimeter by 20 centimeter, 30 centimeter by 30 centimeter for square column, whereas for rectangular column it is of 20 centimeter by 30 centimeter. For circular it is of 20 centimeter diameter or 30 centimeter diameter. Next is doors. The main function of a door in a building is to serve as a connecting link between internal part and also to allow the free movement into and outside the building. It is also part of privacy of a building. The thing you have to remember here is the width and the height of door. As we seen that door provided at entrance is of different size than the door provided for inner rooms and toilets. So the door width would vary with minimum 0.8 meter to 1.2 meter or 1.5 meter maximum. For example, the door width for toilet is of 0.8 or 0.9 meter. For internal room, the width would vary with 1 meter to 1.2 meter. Whereas in entrance, it will be largest among all these. In a similar manner, the door height would vary from 1.8 meter and maximum up to 2.1 meter. The door height of toilets and bathroom or at WC it is of 1.8 meter and at entry and in other rooms it will be at 2.1 meter. The standardization has been kept in door is 2.1 meter as we achieve the lintel level. It remains same in all the rooms and at entry level. So ultimately, the dimension of door would vary with 0.8 meter by 1.8 meter for toilets, bathroom, NWC, whereas 1 meter by 2.1 meter for inner rooms and 1.2 meter by 2.1 meter for entrance of the room. This you have to remember. Next is windows. Windows are provided for proper ventilation and lighting of the building. Remember here, it is provided for proper ventilation and lighting of a building. The width of the window varies with its location and purpose to be served. Sometimes it has been used in a staircase for ventilation purpose, for lighting purpose. It has been used at corner or center for achieving good elevation or aesthetic. So the size of the window would depending upon the purpose to be served in a building. The width of the window would vary from 0.6 meter, 0.75, 0.9, 1, 1.2, 1.5 or 1.8 meter. In kitchen, you require larger opening, so you kept that part open. Whereas the depth of window is also varies from 0.6 meter to 1.8 meter. Next is window sills. It is provided between the bottom of a window frame and wall below to protect the top of wall from wear and tear. Again, the window sills provided between the window frame and wall below to protect the wall from wear and tear. As you have seen that windows is being supported by window frame, and this frame is of rectangular and enclosed in all the dimensions. So the bottom part of a window frame is been fixed to the wall, and this frame is been covered so that we can avoid the wear and tear. The minimum window sill from floor level, or you can say from plinth level, is 0.9 meter. So from floor to the window sill, or you can say the bottom of the window, that distance is of 0.9 meter. Next is a stair. A stair is a structure consisting of steps leading from one floor to another. The position or the location of stair is made in a such a way that it is easy to approach or easy for accessible or easily accessible. The minimum width of a staircase is 1 meter. The staircase is component of successive arrangement of riser and treads. The minimum riser of 0.15 meter, whereas the tread is of 0.25 meter. In staircase, you have seen that there is a platform is been provided to turn the direction of a staircase. That part is called landing area. Landing area is while you are approaching towards staircase, just ahead of riser is a landing area. And for the same, when you put the last feet and reach to upper story, the next area is called landing area. So landing area is while approaching towards a staircase from both the ends, the 1 meter width has been kept open, that is called landing area. Even while turning the direction of staircase, the open space has been provided, that is also called landing area, and that width is 1 meter. Next is lintel. The actual frame of a door or a window is not strong enough to support the weight of the wall above the opening, and hence a separate structure element is provided over door or a window opening. Lintel has been provided at just above the opening of door or a window to support the frame of that opening. The minimum thickness of lintel is 15 centimeter. It is kept above the door height. The lintel level has been provided at 2.1 meter above the floor level. Next is chhajja or weather sheets. They are combined with lintels, and by the composition of these two elements like chhajja and lintel, they provided at window to protect from sun, frost and rain. The projection of a chhajja or weather shade is being measured in terms of width. This projection would vary with 30 cm to 90 cm. At ground level, we are going to provide a chhajja having width of 60 cm. Remember, the width of the chhajja will be 60 cm. Next is parapet wall. It is constructed just above the roof and periphery of that roof slab to protect the people from falling down from the building. The thickness of parapet wall is of 10 cm and the height is of 1 meter. Remember, the thickness of parapet wall is of 10 cm whereas the height is of 1 meter. Next is roof. It is one of the most uppermost part or uppermost component of a building. The main function of a roof slab is to cover the space below and protect the building from rain, snow, sun, wind. There are different types of roof such as pitch roof, flat roof or curved roof. Next is coping. It is provided on top of parapet wall. It prevents the entry of rainwater or moisture from top of the wall and improves the aesthetic of a building. Next is building finishes. They are used to give protective covering to various building components and at the same time they provide decorative effects. Building finishes includes plastering, pointing, painting, whitewashing, distempering, vanishing and polishing and coloring. These are the decorative effects which has been provided for aesthetic and appearance of a building from outside as well as from inner side. Next is building services. These are the essential services which is part of a building component. These are water supply, drainage, sanitation, lighting, electricity, acoustic, ventilation, air conditioning, fire detection, fire control and anti-termite treatment. So these are the components of the building. Remember that you have to focus on the dimension of each component. This theory is being studied in previous semester and also a part of the other subject as well. So our focus is to remember its dimension. So let us have a building section with its dimension. First, we have seen that the foundation as a part of substructure. If a wall thickness is of 30 cm, then the base of the foundation is of 90 cm or 0.9 meter and step footing will be provided with consecutively of 3 layers having its width of 60, 50 and 40 cm. Once you reach at ground level, a plinth level has been provided. The plinth level is of minimum 45 cm. In some of the cases, it has been taken as 60 cm. If I say that the minimum 45 cm, so would you agree that 60 cm is in that criteria or we are satisfying the criteria of that plinth level? Of course, yes. We have satisfied the criteria that is of minimum 45 cm and here I am providing the plinth height of 60 cm. That is okay. So in that plinth, the consecutive of compacted muram or you can say earth filling, then concrete bed, then flooring has been provided and at the building the DPC work has been done. After providing a plinth level, we just reach at floor level or you can say plinth level where a smooth surface is being achieved. Then we are providing doors in the opening The height of door is kept 2.1 meter. It is standard for all. Then windows are kept at same level of the door. Both the elements should finish at same level. The window has been kept 0.9 meter above the floor level, and the bottom of the window is called sill level. So from floor level to the bottom of window, this is called sill level. Next is lintel level. As I said earlier, the lintel level is provided at window and at door level. Here in entry point I have provided, or I have shown a chhajja having width of 0.6 meter, or you can say projection of 0.6 meter, whereas the lintel height is 0.15 meter. At the end of the projection, the thickness of lintel is decreasing, and that is of 0.05 meter, so that you can avoid the accumulation of water at topmost layer of a chhajja. Next is construction of wall having height of 0.75 meter. So the total lintel level or total lintel height is 0.9 meter. So from bottom, again I am repeating, from here 0.45 meter minimum, then 2.1 meter, then 0.9 meter. Ultimately I will reach up to a slab level. This height is of 3 meter. So the total floor height or single story single floor height from floor level to slab level is 3 meter. You have to remember this section and the dimension of each and every component. Once I achieve the slab, I will provide a parapet wall inclusive of coping having thickness of 10 centimeter. So this is what the building section with its dimension. This is a sample. This would vary with the design and the section of a building. So this is a sample layout for your understanding of building components, its arrangement and its dimension. I'm ending this session here. Thanks for watching this video. I hope you have learned the basics of building components with its dimension. Thank you.